Fine, Steve. Yeah, it was a bit of a surprise for me to be asked to hold the keynote. And well, usually you hear in keynote stories about we all save the world together. Well, I decided to do something different for a change and, well, give you a short history of everything with a short look back and, well, with everything, of course, I mean Vissim, because that's what I've been working on for 30 years. It all started a very long time ago, and in 1972, Rainer Wiedemann, in his PhD thesis, produced the first ideas of a car following model for his PhD thesis. And that was just two cars following each other and with different interaction states. And the source code for that was written in Algol. Of course, it was on a mainframe computer with punched cards. And well, here you can see at least a printout of the very first version. And well, this development resulted in his PhD thesis, and that is what is nowadays known as Wiedemann 74, which is basically the publication which contains that very basic car following model. So with different states, vehicle approaching a slower vehicle, and then at some interaction threshold, noticing that slower vehicles starting to decelerate, and then eventually being in the unconscious following state where it basically tries to keep a certain distance, depending on the speed of the leading vehicle, of course, and well, but kind of oscillating around that distance. And then Rainer Wiedemann became professor at the Institute of Transportation Studies in Karlsruhe, and lots of scientific assistants did things to that software. And eventually, Hans Hubschneider, the founder of PTV, in his PhD thesis, built the program, the new version called Mission. And this one already had not only one link, or rather one lane, which was in Wiedemann's model, but building blocks to have a network, even with intersections, multiple lanes, and it already had things like priority or even signalization, and then getting data out of this. This was coded in Simula 62, still on a mainframe. And then, again, 7 years later, Peter Fortisch ported that to a PC. And he ported it from Simula to Modular 2. And here you can see that MS-DOS version, and it even had a visualization. So as you can see, obviously there's one link. Well, it's in two parts, and the vehicles are moving from the left to the right. If you have double letters, it's trucks, and the single ones are cars. And well, there you can now you can even see what happens there. Of course, that was still, well, visualization only for that one link. And soon after that, Martin Fellendorf, who had also finished his PhD at the KIT then and went to PTV as well, most of the people from that institute at that time. He brought with him the source code for Mission in a way, and an agreement that PTV may build a commercial product starting from that source code in a way. And the university in exchange has the, well, lifetime usage rights for the products which are developed from it. He also started talks with Siemens, who at that time were the, well, lead customer and a distribution partner. And so the focus of Vissim in the first time was mainly signal control. And Martin not only brought the source code with him, but only one guy who, together with Peter, then started porting the code again from modular 2 to C. And I had finished my master thesis building a very Siemens-specific controller, which was used in Karlsruhe into the mission code, which was, had lots of parameters and was, died very few years later. But at that time it was still used in Karlsruhe, and we could do some projects there. And at that time it was still MS-DOS. There was no Windows yet, and we used the Borland graphics interface, which then looked like this. Actually, well, quite similar already in a way. It looks like Vissim, doesn't it? Actually, why have we done anything since? So you have the like log files or windows at the right, and the signal times table, but you might notice, for example, here in the middle the links, there were no connectors yet, and there was no network editor. So you had to write down the network structure in a text file. And we just moved from one link to another by describing the two positions basically. And then they jumped from that position on link 1 to the other position on link 2. And that was relatively short-lived, because at that time Windows came on the market, and then we had luckily we at PTV, we had two master theses from students who built a Windows GUI and a network editor. So lots of students work there all the time. And we used a toolkit at that time, the XVT toolkit, which allowed us to build versions for Windows and for HP UX, which is a Unix version on HP machines, because Siemens at that time sold those machines with a Siemens sticker on them with their traffic engineering software and the controllers. And so they said we need the simulation software for the same machines. So we had that toolkit. Funnily, like already, I think 3 years later or so, Siemens and PTV both found a contract saying, oh, no, now Siemens has to buy 25 licenses of this Unix version. And at that time, none of the Siemens users still used those machines. Everyone used Windows, and we hadn't built a Unix version for a year or so. So we happily agreed to change that to Windows. Because, that was just the time when everybody got a Windows machine and everything was Windows. And of course, in that network editor, we then had links and connectors. We had improved the car following, for example, that a car could see through the leading car to see a signal, which is quite nice, because the last car passing in amber might still be fast, and if the second car doesn't see the signal before, it will be too fast to brake. And things like that, which were just not in the original car following model. So you always have to remember in a way that Wiedemann's car following model was for two vehicles following each other on one lane. That's it. Then things like lane changing models had been added to Mission already, and parts of those are still in Vissim, but there were many things we had to add for specific situations. For example, another thing was a bus in a stop, like 10 meters away from the signal. In the original Wiedemann following model, after stopping, the bus would just stand there, because why should I 10 meters? I cannot go, it's red anyway. So it would not go on to that stop line. So we had to add many more specific handling for such situations. We also added a signal controller type VS Plus at that time, working together with colleagues from the Verkehrssysteme Plus AG in Basel, Switzerland. And so after, I think, Switzerland having been the first international step of Vissim, then Martin Fellendorf made sure that we also find a much bigger market, which was also much more prepared in a way for Vissim. And there was that small company, ITC in Corvallis, actually, later Portland, and with Thomas Bauer and Jim Dale. And well, they agreed to not only to do projects with Vissim, but also to act as a distributor. And from that, eventually, we developed together that, with the help of third parties and building the GUI code, GUI code at ITC, the NEMA controller. And in the US, it turned out well, traffic engineers were much more keen to use simulation software. There had been CORSIM, of course, but that was not comfortable to use at all. And in I think it felt to me quite different from Germany, where the regulations did not say anything about simulation. It didn't say anything in the US either, but still in the US, the practitioners were interested in seeing what their signalization does. And well, looking at the actual outcome of especially actuated signalization is really a good thing you can do with well, traffic simulation. So for the next few years, we still focused on signal control. Vissim was part of the Siemens traffic engineering suite and was called Simula Plus. There, funnily, we had a different headline for Siemens, the Siemens version. New Siemens controller types, the traffic language from Siemens, and VAP, again, originally a project of a student's master thesis. Well, most of you will know it, say, signal basic, specifically for formulating single controller logic with Vissim. And well, we added things like static routes, PT lines, more evaluations, delay measurements, and so on, and also animation recording and replay. And then the big next step was in 1997, when Volkswagen approached us, and they wanted, well, to save the world by doing emission calculation. And the plan was to do emission calculation for the whole city of Braunschweig, which is about 300,000 inhabitants. And so we had to do some bigger changes to the code. For example, for emission calculation, we had to go to 10 time steps per simulation second. The 1 second was not good enough or high resolution enough for their model. And we had to add vehicle types and vehicle classes, of course. Trucks have quite different emissions from cars. We didn't have, and then you can distinguish further between different classes with different emission behavior. And well, the biggest thing probably was the dynamic assignment, which we started at that time. So a way not to have to enter the static routing for all intersections of the whole network, but for by a way to have the vehicles find their way themselves somehow. And another few years later, and This time it was not a student but a PTV employee, but he had experimented privately or in his free time with 3D and said, why can't we do some 3D visualization? And he did it, and well, it was just great. Came again at the right moment before some competitors had it, and so we were lucky again to be there with the right feature at the right time. In the following years, we were then more features for vehicular traffic. So, well, we added left side traffic, so it could be used in the UK and some other countries who decided to follow that. It was not before that time, so only like 20 to 25 years ago, not the 30, that we had used or started to have the continuous lane change. Before, vehicles just jumped from one lane to the other, and now, well, from that time on, they really had that lateral movement, and which was also affecting then the other vehicles. We also implemented a new car following behavior from Professor Wiedemann 99. Basically, mostly simplified it was. But for Vissim, the main difference is that more of the parameters of that behavior model are available to calibrate it. Then another big one was the non-lane-based traffic, which started with bicycles. So there were requests for modeling bicycle traffic, mainly from China, where they had then like bicycle paths with 15,000 bicycles per hour. And that's a lot. I think they were 6 meters wide, so okay, enough room, but still, that's like, well, the bicycle traffic you have maybe in Karlsruhe on a whole day in whole Karlsruhe, and not at one place. And later we used this also for, traffic like in India, for example, where you have many different types of vehicles, so it's like scooters or even rickshaws, and well, 2, 3, 4-wheelers all together. And well, if there are lane markings, they are only considered well, a hint, but not more. And so we built a model to be able to try to simulate that kind of traffic. Of course, there are situations if there are intersections completely blocked through with this kind of traffic in different directions where you still cannot do it, but well, we keep working on it. And then we added several interfaces at that time, the API for programmatic access to use Vissim in combination with other programs or to let it do specific things from your program, the COM interface, and then the different DLL interfaces. And again, other evaluations like node evaluation, the NPE, and for visualization, AVI recording. At that time, we had snapshot files, which is a feature. Well, I think that's maybe the main feature which is not yet there again after the re-engineering. But at that time, it was really a difficult feature because it mostly worked. It mostly almost worked. So. And each time when we had to add a new parameter somewhere in a vehicle, we had to remember to put that also in the snapshot. And yeah, usually, or in let's say at least 1/3 of the times, this was forgotten, and so the snapshot forgot this, and yeah, it never really worked fine. So we'll see if we get it again. Of course it's still on the list, but that's one thing we had there. We also added real parking spaces, so not only like zone connectors or the abstract parking lots for dynamic assignment and for like static parking routes. We started experiments in multi-threading. There were actually two different ways to do it. We had an experimental version where we could actually distribute one simulation over multiple machines. By cutting the network geographically. And that was just before the multi-core processors appeared. And as soon as those appeared, we found that it's easier to do the internal multi-threading and not split the network anymore, because we had quite some overhead. Actually, the speed improvement was in a way similar with that MPI technology there, the first one. As with the internal multi-threading we have now, which is about, we can get to a factor of about 3 times single threaded speed with, say, 8 cores or something, and that was similar at that time again. Then conflict areas, yeah, were another thing we added, and A&M import, so there were more and more requests to be able to somehow use things, use networks from Vissim in Vissim. And well, so we built that interface. And then the next big thing I would say was the pedestrian simulation, which we released in 2008. Well, with a whole new part of the network editor with whole new objects, network objects for pedestrians, and that behavior model, and which is also completely different. With I think if you have been in the workshops yesterday, you've heard a little bit about it, and well, it consists of forces which are affecting the pedestrians. The force leading them into the direction they want to go, and then forces from walls and other pedestrians which are pushing them away. And well, the total of that forces is where they go, which is sometimes not very clever. So they might miss a door or so on. And yeah, we are thinking about possible other models, but in the meantime, there are so many additions to it, and you can calibrate it so that you actually can model the behavior of the a larger number of pedestrians quite well, even if sometimes an individual one might look strange what they do. And right now we are in the process of re-engineering that, but well, after the pedestrian implementation came the phase of Vissim R, which was the re-engineering, the big re-engineering of the internal architecture of Vissim, and which consisted of trying to do, well, most things in a generic way. So we had code generation for all the attributes of the objects, and a command processor, a generic attribute interface, and all this allowed us to, well, get new features like result attributes, list windows, the quick view window, and the COM interface where you have access to all attributes of all objects quite easily, and well, especially doing things allowing us to add new attributes at one place and then having them available everywhere. That's the main thing we got from this. And well, we got undo, which was the only, or maybe at least the first standing ovations situation I've got in a UGM, because it had been asked every year before, can we have undo in the network editor? And I said, of course, if you like, wait for 2 years and don't want any other features, we can do that. And in a way, it worked like that. we worked more than 2 years on the re-engineering, and yeah, I remember quite well the UGM in Minneapolis, I believe, in 2012, when this person said we had to decide, do we do a company video or do we do Vissim 6? And we have decided to do a company video. So because we were not quite ready. That was the 1 year where we didn't have a new main version in Vissim. Yeah, and well, after that, we've added many more features. You will know most of them, I guess. The live, rather online maps, backgrounds, chart windows, scripting, of course, not only from external scripts, but the event-based scripts called from within Vissim. Nowadays, partially replaced through attribute modifications. Then scenario management, another thing which gets some useful additions in the new version. We added user-defined attributes, also only possible through the re-engineering. And well, then things like for dynamic assignment, matrix editing and matrix correction, the equilibrium assignment, and visualization, and well, that's the new special editor states. You might know them if you do, for example, car park modeling, or yeah, the new simple ITS simple controllers. And well, the last big development maybe, or the last two things were mesoscopic simulation and parking in reverse, which has basically only finished now in the new version.